Hey kiddos. In our last lesson, Unit 5, Lesson 1, we discussed adding, subtracting, and multiplying polynomials. Today we're going to do division with polynomials. So to divide a polynomial by a monomial, we divide each term of the numerator by the term in the denominator. And so we will need to recall our exponent rules, the quotient rule for this one. All right, now, if we are not able to divide a polynomial, what we do is we will factor it. Just remember that factoring, so here's my example with number 12. Factoring is not doing anything to change this value. It is just breaking it down into smaller parts that make it up. So 3 times 4 is just a different way of showing the number 12. And that's what we're going to be doing with our polynomials. We're going to be factoring them today as well. So our different methods of factoring, you should recall from Math 1. First and always, we do our GCF. The way that I describe this is that we pull out or divide out a common number and variable from each term, and then we wrap up the leftovers. So here's how our answer will look. The GCF on the outside, the leftovers on the inside of parentheses. Okay. Second, we have a difference of two squares, where the A term is a perfect square and the B term is a perfect square. So examples of this could be x squared, y squared. You could even do x to the fourth, y to the fourth, because 4 is a perfect square. On our numbers side, so the different numbers that we have that could be squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And there's the whole list continues, okay? 6 squared, 7 squared, 8 squared, 9 squared, 10, 11, and then 12 is 144. Okay, so here's our list of perfect squares. The one that students miss most often is 1 squared. Okay, so if you want to highlight that one so that you remember it, and we're going to look at some examples. A trinomial, we're going to go over this process with you, but we should have learned all 3 of these methods in Math 1. Okay? The only new type of factoring that we're going to discuss is grouping, which uses GCF and leftovers, and that's about it. So we're going to look at examples of all 4 of these. Okay? So let's start first with an example that is simply dividing a polynomial by a monomial. And so we're going to do this in 3 parts. Okay, we're first going to just do 18c cubed divided by 3c. 18 divided by 3 is 6. C cubed divided by c to the first power, that's 3 minus 1 is 2. Okay, now let's do 21, or negative 21, divided by 3 is negative 7. C squared divided by c, that's 2 minus 1, is just c. And then finally, our third one here, 3c divided by 3c. Well, 3 divided by 3 is 1. C divided by c would be c to the 0 power. 1 minus 1 is 0, which equals 1. So my final answer is this trinomial right here. Alrighty, let's look at example 2 and go ahead and factor this by greatest common factor. If you had me for Math 1, I showed you that I always break this down. But if you did not have me for Math 1, I'm still going to go ahead and show it that way anyhow. So 6, let's factor the number 6. It can be 2 times 3. And I'm also going to break down this y. There's 4 of them. Okay, 4 y's. Let me zoom in a little. Okay, now I'm going to break down 14. That is 7 times 2. And there are 3 y's with this term. I'm going to keep the plus sign in the middle. I'm going to keep this minus sign in the middle. All right, now I'm going to break down 10, and that's the same as 2 times 5. And then there are 2 y's. Okay, so here's what I'm going to do now that everything is broken down. I'm going to go through, and I see that they each have a 2. So I'm going to put a 2 out front. I'm going to take a 2 out of each one of them. Second thing that I see that they all have in common is a y. Okay. And then what else do they have in common? I see another y. They each have another y. Okay. Now, I can't take out any more y's because this term in the back doesn't have any more to take. So I can't take something from one of these 2 terms without taking it from this one as well. So that is my GCF right here. Okay. GCF is 2 times y, which if I simplify that will give me 2y squared. Okay. Next, I'm going to bring down my leftovers from each of the 3 terms, and I'm going to put them in parentheses. So I have 3yy plus 7y minus 5. Those are all my leftovers. And so all I need to do when I bring it down is just clean it up. 3y is the same as 3y squared plus 7y minus 5. And this is my final answer, just factoring by GCF, or greatest common factor. Let's do an example with difference of squares. Difference of squares. Notice that this is a perfect square, 2 times 2. This is a perfect square, h times h. This is as well, 5 times 5, and g times g. So here's what's going to happen. I am going to take this minus sign, and I'm going to break it up into 2 binomials, where one of them will be positive and the other will be negative. The reason that I do that is because the only way to get to a negative 25 is to have a positive 5 times a negative 5. If you multiply those 2 numbers together, you get your negative 25. Okay, now I'm just going to go ahead and put the g's behind the 5s, break them up evenly. Same thing in the front. I've got a 2 and an h, so I'm going to break it up and put it in the front. And a 2 and an h, break it up, put it in the front. And that is your final answer. So when I have perfect squares, I just break them up evenly. If it started as the first term, it stays in the first term. If it started in the second term, it stays in the second term. And I just need to remember to do 1 plus, 1 minus. And that's factoring by difference of squares. It's really easy once you recognize it. All right, let's do an example of grouping before we start discussing our trinomials. So with grouping, if you notice by looking here that they do not all have terms or a GCF that I can take out of all 4 terms. So what I do is I break it down into the first 2 terms and the second 2 terms. And I treat this just like I did in example number 2. I'm just going to take out the GCF of these 2 terms. Okay. So k cubed and k squared. Well, they each have 2 k's in them. So let's take out k squared and then leave the leftovers in parentheses. So 3 minus 2 is 1k, plus I have a 2 here, and I took out both of those k's. So that's it. I have factored the first term. Now let's factor the second term. -5 and -10. Well, I can take a -5 out of both of them. Okay, -5 divided by -5 is just 1 times k. -10 divided by -5 is +2. So I have factored the second 2 terms by GCF. And here's what's kind of neat that happens. So notice that this k plus 2 and this k plus 2 match. Well, that is going to be the second term in my final answer. And then what I do is I take both of the GCFs and I put those together. So k squared was the first GCF, minus 5 was the second GCF. And I put those together. And this is my answer. Now, if for some reason your leftovers do not match, then you've done something wrong. The leftovers must match. Okay? Alrighty. So that is by grouping. Let's take a look at our trinomials, factoring our trinomials. So again, if you had me for Math 1, I taught you factoring using the X puzzle when we did trinomials. Okay? So let me go ahead and pull up our rule. The rule that we're using is this one right here. So in the top of the X puzzle, we should have A times C. So A in this case is 1. 1 times C, so that's 1 times -72 is -72. And then in the bottom is the B term. B goes in the bottom. So that's a -14. So here's how my X puzzle will look in this situation. Now my goal is to find the 2 factors, the first factor and the second factor. So that's what this F1 and F2 is. These are my 2 factors. And they need to multiply together to give me -72, but they need to combine by addition or subtraction to give me -14. All right. So what you can do is start breaking down what are your factors of 72. This is the easiest way to do it. So I'm going to list the factors. So obviously 1 times 72, 2 times, let's see, 2 goes into 7 3 times with 1 left over. It goes into 12 4 times. Okay, let's divide 72 by 3 now. So 3 times 3 goes into 7 twice with 1 left over. 3 goes into 12 4 times. Whoops, I did this wrong. 2 goes into 12 6 times. Okay, so 3 times 24. Will 4 go into 72? Evenly. 4 goes into 7 1 time with 3 left over. 4 goes into 32 8 times. So yes, 4 times 18. 72 is not divisible by 5. Is 72 divisible by 6? Let's see. 6 goes into 7 1 time with 1 left over. 6 goes into 2 or 12 2 times. Okay. So 6 times 12. It's not divisible by 7. It's not divisible by 8. It is divisible by 8. Let's see. 8 times 9 is 72. Okay. And then we would wrap back around 9 times 8. So my list is done. I listed all of the possible factors of 72. So one of these numbers has to be positive and one of them has to be negative. That's the only way to multiply two numbers together to get to negative 72. Now, how do we decide which of these sets of numbers would combine to equal a negative 14? Alrighty, well, just take a look at the numbers and see which ones could possibly add up to 14. So 8 and 9 is 17, or 1. Okay, 6 and 12 would be 6, or 18. 4 and 18 would be either 22 or 14. So this is a good combination. This is a good set of factors. Now I just need to decide which one should be positive and which one should be negative. So if I do negative 18 plus 4, I'll get to my negative 14. So now what we're going to do is we're going to take our two factors and we're going to write them out into parentheses. So when we put them in our parentheses, we need to change their signs. X minus 4, x plus 18. And the last step here says that I should divide them by a, since I multiplied by a. Well, a is just equal to 1. So you could show that you're dividing by 1 just to keep your steps, to keep them systematic. And so my final answer is still just x minus 4, x plus 18. And that is our final answer, kiddos. So I want you to notice that when we take these factors out of the X puzzle and put them into parentheses, we need to change their signs. Notice that I have minus signs here. Okay? All right, so that's example number 5. Let's take a look at example number 6. Same exact process. So I am going to multiply 2 times 3 and get 6. I need to come up with numbers that multiply to give me 6, but add or subtract to give me a positive 5. And in this case, it's really easy to list your factors. It's 1 times 6 or 2 times 3. That's it. So obviously, the way to get to 5 here, when everything is positive, is to do 2 plus 3. So I'm going to go ahead and take these factors, put them into parentheses, changing their signs. X minus 2, x minus 3. And then because I multiplied by the A, I need to divide everything by the A. And so in this case, I can go ahead and simplify these now. -2 divided by 2 is 1. And when we have a situation like this, I like to tell you to do your bottoms up. Take whatever's in the bottom of a fraction that is not able to be simplified to a whole number, and you're going to move that number to the front. So I call this bottoms up. Okay, just for fractions that don't simplify to whole numbers. So, and it goes up to the front. So 2x minus 3. And that is our solution for number 6. All right, let's move on to our next example. And this is what happens if something is not able to be factored. Okay, so think about the number 13. We can only divide that by 1 or itself. Okay, so 13 is a prime number. Well, occasionally we get a polynomial that we cannot factor as well. And so that would also be considered prime. So 2x, 3y minus 13. None of those coefficients, 2 or 3 or 13, have any numbers in common other than 1. And the variables x and y also do not have anything in common. So we can't factor that any further. That is as small and as simple as it gets. So this is also considered prime. So let's take a look at these over here and decide which of these are factorable and which of these are prime. Okay, so the very first one is x squared minus 49. We can factor that by difference of squares. So break apart the x's. They go in the front because the x squared is in the front. Break apart the 49. That's 7 times 7. And then one will be negative, one will be positive. So I can factor this one. All right. What about the second one? 5a minus 18b. Well, 5 and 18 have no common factors. A and B have no common factors. So this one is prime. Okay. What about this one? Y squared minus 2y plus 10. Well, I can factor this one. This is a trinomial, okay, where I would get 10 on the top, negative 2 on the bottom. So the two numbers that multiply, let's see, is there anything? I think I can factor it. Well, 10, there's only two ways to do that. That's negative 10, well, 10 and 1, and 2 and 5. Okay, so the only way for this 10 to be positive is for both of these to be positive or both of these to be negative. So 5 and 2 would be 7 or negative 7. 10 and 1 would be 11 or negative 11. So this is prime because I can't factor it using my X puzzle. So prime. But when I see a trinomial, I do want to try to factor that out. Okay. What about this one? 2w squared minus 5w minus 12. Well, let's do 2 times negative 12 and try this X puzzle. Be negative 24 on top, negative 5 on bottom. And I want to come up with factors that would multiply to give me negative 24, but combine to give me negative 5. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, and I believe that's it. So let's see, one of them has to be positive, one has to be negative. So the larger one would have to be negative to combine them and get a negative 5. So 1 minus 24 would be negative 23. 2 minus 12 would be negative 10. 3 minus 8 would be, negative 5. So 3 and negative 8. So this is factorable. This is factorable. My solution would be x minus 3, x plus 8. So that is factorable. Okay, what about this one? I believe I can do this one by GCF because that has a 3 and that has a 3. And so I can take a 3 out of both of them. And then my leftovers would be m squared minus 1. So this is factorable. And then finally this one, x squared plus y squared. Well, it reminds me of a difference of squares because I have a square in the front and a square in the back. However, it has this plus sign. So the name difference of squares matters. It has to be a minus sign in the middle. So this one is also prime because it has a plus sign. All right, so we just identified 3 different polynomials that are prime. Great job. So if you cannot factor them, then they are prime. Now, some students fall into a situation where they don't exactly notice by looking at it how to factor it, and they think that it's prime when it actually is not. You could factor it. So just always look for that GCF first, and then after, if there is a GCF, see if you can factor it further, okay? All right, so let's take a look at this and mix some things up. Let's mix some things up. So I see 2, 30, and 72. And I know that every one of these are divisible by 2. I can divide them all by 2. So 2 is going to be my GCF. Okay, so let's take this out and see what my leftovers will be. 2 divided by 2 is 1, so that's y squared. Negative 30 divided by 2 is negative 15. 72 divided by 2. 2 goes into 7 3 times. And with 1 left over, 2 goes into 12 6 times. So each of these numbers was evenly divisible by 2. So there's my GCF. Now I need to look and see, can I factor these leftovers? Okay. So let's do the X puzzle. So the very first thing I looked for was a GCF. 2 factor further. I'm going to always try to factor this further, okay? So 36 goes in the top. 1 times 36. Negative 15 goes in the bottom. Now let me go ahead and list my factors of 36. So I've got 1 in 36, 2 and 18, 3 and 12, 4 and 9, not 5, 6 times 6. Okay, so these are all my factors of 36. Okay, let me just make this neat little box here. Factors of 36. So now which combination of these numbers do we believe that we could put together and get a negative 15? So if this is positive, the only way to get a positive 36 by multiplying 2 numbers is for them both to be positive or both to be negative. So let's see what would happen if we're just going to combine them, right? 36 and 1 is 37. 18 and 2 is 20. 12 and 3 is 15, so that looks promising. 9 and 4 is 13. 6 and 6 is 12. So the only one that I really noticed here was 3 and 12. Now, how would I put signs there to make them negative 15? Well, negative 3 And negative 12, if I combine them, is negative 15. But if I multiply them, is a positive 36. So when I pull these out into my factors, remember to change the signs. So I'm going to bring down this GCF of 2. And then I'm going to bring these factors over to here. Y plus 3, y plus 12. And then don't forget to divide by that 1, which won't change the values of anything. So here is an example of where you can pull out a GCF first and then continue to factor your leftovers even further. Great job. Let's go take a look at example 8. This is probably about as hard as it gets, guys. We are going to combine everything that we learned from Unit 5, Lesson 1 with what we've learned today. Okay? So the first thing that we need to go ahead and do is multiply everything out. So 4y minus 5, 4y minus 5. I'm doing that because of this square. Okay? And then let's see, I'm going to go ahead and distribute. Negative 3y times 4y is negative 12y squared. Negative 3y times 5 is negative 15y. And then just bring down these in the back. Okay. All right, now I'm actually going to go ahead and multiply this out. And I'm just going to use our distributive property. 4y times 4y is 16y squared. 4y times negative 5 is negative 20y. Negative 5 times 4y is negative 20y. Negative 5 times negative 5 is positive 25. Let's bring down everything else. Negative 12y squared minus 15y minus y plus 27. Whew, that's a lot of terms. It's 1, 2, 3, 4, 5, 6, 7, 8 terms. But we can combine some of them. So let's see what happens when we combine them. So I'm going to use my different color pens. I have 16y squared minus 12y squared. 16 minus 12 gives me 4. 4y squared. Now let's do all my y's. Negative 20 and negative 20 is negative 40. Minus 15 more is negative 55. Negative 56. Ooh, negative 56y. And then I'll switch to purple. I have positive 25 and positive 27. That is going to give me a positive 52. Positive 52. All right. So now I am ready to factor. I'm ready to factor. Let's see. Is 52 divisible by 4? Yes, it is. And 56, is that divisible by 4? Yes, it is. And 4 is divisible by 4. So I'm just looking at each of these to see if they're divisible by 4. Let me show you how I'm getting that. This is the same as 4 times 1. This is the same as 4 times 1, 4 times 14. And this is the same as 4 times 13. Okay, so all of them are divisible by 4. Why did I not look for something bigger? Well, the smallest number is 4. So that is the largest possible number I could take out of the rest of these. So 4 is my GCF. Okay. So I'm going to pull that GCF out and I'm going to write my leftovers. So I have 1y squared. I have minus 14y, and then I have plus 13. Okay, so let me just draw a line here. So this is what I now have. Can I factor what's inside of these parentheses even further? And I can. So I'm going to come over to the right, work my X puzzle out. So 1 times 13 is 13. Bring down the negative 14. Now 13 is really easy to find all the factors of. It's only 1 in 13 because it's a prime number. So how could I put possibly 1 and 13 together to get to a negative 14? What if I made them both negative? Negative times negative is positive. Negative 1 minus 13 is negative 14. So I was able to factor this further. So remember, when you put them inside your factors, you have to change the signs and bring down your GCF. Alrighty, so this one problem completely combines the last two lessons all together. That is the biggest problem that you will ever probably see, okay? Let's just look at one word problem example. A ceremonial red carpet is rectangular in shape, and it covers this amount of square feet. If the width of the carpet is 4 or x plus 4, express the length in feet. So they're giving me this carpet, and it is x plus 4 wide. How long is it? So what they gave me here is the area. The area equals 2x squared plus 11x plus 12. Well, we know that area is the same as length times width. Okay, so I just kind of jotted that over there. So length times width. So I could factor this all the way out by doing 2 times 12 is 24. Bring down the 11. Okay, I know that 3 times 8 is 24. And so if I did negative 3 and negative 8, I'd get negative, I got to do positives, don't I? Positive 3 and positive 8 to get to a positive 11. And so I'd have x plus 3, x plus 8. But remember, when there's that number in the front, we don't want to forget that we multiplied. So now we have to divide it out. Okay. 3 over 2 is not a whole number, so I'm going to do my bottoms up. 2x plus 3, and then 8 divided by 2 is 4, so x plus 4. So they had already given me the x plus 4, which I found right here. This was the missing length, okay? So the length is 2x plus 3. Now let me show you how you could have done that, okay? Another way to have done it would be if I already knew that I have an x plus 4, what would I need to multiply the x by to get to 2x squared? I would have had to have multiplied it by 2x. 2x times x is 2x squared. And then what would I had to have multiplied the 4 by to get to 12? Well, 4 times 3 is 12. Okay, so I could have also done it that way. All right, kiddos, so here is our last couple of examples that we've just done. You will definitely want to practice your factoring. I'm not sure if you were able to get to this in Math 1 last year or not. but we will be using factoring for our next unit or two. So we want to be really skilled at this, just like we were at solving equations. So we're going to go ahead. There's lots of practice for you, okay? So go ahead and get started on that practice, and I'll see you next time.